mixture of ammonia and a carrier gas is introduced and maintained at temperature for several hours. During this time, the nitrogen in the ammonia combines with the iron in the steel to convert the surface of the steel into an extremely hard epsilon iron nitride to a depth of between 1,000th and 15/10,000th of an inch. Following the nitriding cycle, the steel is oxidized, creating a black surface film of iron oxide 1 or 2 microns thick, which provides additional corrosion resistance. The steel is then quenched in an oil and water emulsion. The results of the Nitro-Tech process can be seen in this photo of standard Nitro-Tech 1045 at 200 times magnification. The light area on the right is the copper cladding used in the sample mount. The thin black line next to it is the film of iron oxide on the surface of the steel. This film coats a thin, uniform, and extremely hard, between 64 and 71 on the Rockwell C hardness scale, wear layer of iron nitride. If you look closely, you'll see that the iron nitride layer has what is called columnar porosity to about half its depth. This controlled porosity allows the iron oxide to fill the pores, which dramatically increases corrosion resistance. In addition, the oil-carrying capability of the pores significantly improves surface lubricity and further contributes to corrosion resistance. Beneath the iron nitride wear layer is a nitrogen-enriched diffusion zone, a light, shallow hardened case which provides excellent support and dent resistance to the wear layer without creating the machining difficulties inherent in induction-hardened products. Nitro-Tech process products offer well over 100 hours of ASTM B117 neutral salt spray corrosion resistance. A second polishing and oxidizing sequence, the Nitro-Tech S treatment, can give over 250 hours of resistance. Plainly put, the Nitro-Tech process produces a product that meets or beats chrome plating in all performance criteria, and field applications have proven it. In Texas, a Nitro-Tech treated piston rod and a hard chromium plated piston rod were installed at the same time in the mass tilting cylinders of a forklift truck used at a chemical processing plant. The chromium plated rod has been replaced 6 times. The Nitro-Tech rod was said to be still like new. Guess what kind of rods are now specified? The Hatterty Machine Company of Lansing, Illinois, maintains equipment at a steel mill coking facility in East Chicago, Indiana. They were replacing hydraulic cylinder rods monthly in a hostile environment that included a good dose of ammonium chloride. Hatterty tried Nitro-Tech treated rods. They lasted a year. Hatterty began using a lot of Nitro-Tech rods. And as far as the U.S. military goes, they not only get longer field service, but did you ever try to camouflage a shiny chrome-plated hydraulic piston? So there you have it. Chrome looked great. Chrome was shiny, but the shine was just a glossy reflection of the times. Things are made to last longer now. Nitro steel bars and tubes are available in 12 and 24-foot lengths, ISO 9002 certified. They are competitively priced and help you make products that outperform the shiny stuff. Nitro steel products machine, weld, and handle like pre-plated chrome, yet have better wear properties, better corrosion resistance, tighter tolerances, and no environmental hazards. Times change. You can face it now, or you can face it later. But change is inevitable. Nitro Steel gives you a change for the better.